Hello, welcome to the class on the Earth. My name is Laura Lewis. So this is suitable for Key Stage 3 up to Key Stage 4, that's the introduction to the Earth. So let's look at the learning objectives. So number 1, an understanding of the Earth's place as a planet in the solar system. Number 2, an overview of the structure of the Earth and its atmosphere. Number 3, how to answer questions on the Earth and its systems. Okay, so let's go to the next slide. I'll click it. Okay, so let's have a look at the start. So how did the Sun and the Earth actually form? Okay, so in the picture there is a very beautiful formation called a nebula. Okay, that's actually the Orion Nebula. Whilst I'm filming this, we're coming up to winter, and that'll be in the sky pretty soon. It's in the constellation Orion. It's called the Orion Nebula. But what this actually is, a nebula is a star and planet forming region. So it's where stars and planets form. So a nebula is quite a simple object, really. It's just a very large cloud of gas and dust. So when we say large, they are bigger than the solar system. So some are light years across, these clouds. We can see them from a very long way away. They are lit up. We think why are they lit up? They're lit up by the stars that are forming in it. Okay, so they don't really light themselves, but they're lit up by the stars forming in it. So nebula are huge. Okay, so they've got a lot of gravity acting on them. So the bigger the mass of something, the more gravity acts on it. So what actually happens is gravity pulls the gas and dust together. So the nebula is collapsed by the force of gravity into a spinning disk. Okay, so it pulls together in a spherical shape and is actually rotating a bit. Okay, this formed the Sun. The leftover gas and dust forms the planets. Okay, so really planets are kind of just left over from the formation of stars. So they formed at approximately the same time. We can actually see planets and stars forming in nebula today, like in the Orion Nebula. We can actually see them, like little clumps of gas forming. And those little blue stars that you can see, okay, are new stars that are forming. Some have got little fuzzy patches around them. That's gas that's still around them from their formation. It's very beautiful to look at in the sky. Okay, so this is an overview of how the planet's formed. So the heavier material, okay, such as metal and rock, the rocky metallic elements stay closer to the Sun, forming the inner planets, Mercury, Venus, Earth, and Mars. Whilst lighter materials such as hydrogen, helium, and other gases moved further out to form the gas giant planets. So as the disk was rotating, the heavier elements stayed closer to the center, and the lighter were sort of flung out into the outer parts of the solar system. Okay, again, actually, while I'm filming this, the planets are Jupiter and Saturn and Uranus are actually in the sky at the moment. It's always good if they're in the sky. It's a good opportunity to look through them with binoculars or telescope. Honestly, it's worth it to have a look at them. They're very pretty gas giants. Okay, so a little bit more on the Earth itself. We're sort of focusing on the Earth today. So we've got overall, so we're going to go into more detail on the next slide, but this is the overall. So again, the heavier material, the heavier metals sank down into the core. So we have the inner and the outer core, okay, made of iron and nickel. The inner core is made of solid iron and nickel because it's under a lot of pressure, okay, and the outer core is made of liquid iron and nickel. That's actually where our magnetic field comes from, is that the inner core, so an inner and the outer core rotate with the Earth. So it gives us the Earth a magnetic field, okay, a big magnet. So the lighter material, the rocky material, lighter compared to the metal, floated to the top. We've got the mantle made of semi-molten rock. It's not quite as you see as lava because it's under pressure, so it's actually more solid than that. It can move, but it's called viscous, like sticky. So It's harder to move than sort of like a lava you see coming out of volcanoes. Now, the crust made of solid rock. I'll go into a little bit more detail here. Okay, so we've got the inner and the outer core, and yeah, it's the reason for magnetic fields I just said there. Right, so I'm going to a little bit into more about the mantle. Okay, so the mantle is split into semi-solid, again semi-solid, not completely liquid and not completely solid, mesosphere and a asthenosphere. The tectonic plates sit on the mobile asthenosphere. This is mobile means it can move. Okay, so the crust is part of the lithosphere. So the crust that we stand on is the upper part of the lithosphere. Okay, and it's on the solid part of the Earth. Okay, so let's go back to, we're going to talk about how the atmosphere forms. So we're going to go back to the early Earth. Okay, so we're just going over it again. Okay, we have the rocky inner planets, Mercury, Venus, Earth, and Mars. So Mercury doesn't have an atmosphere, which we'll talk about in a different video on planets. Venus has a very thick atmosphere. Mars doesn't have much of an atmosphere. It has a little bit of carbon dioxide, but Earth has an atmosphere, a bit more complex one, which we're going to focus on. Okay, so all of those planets are similar in a way to the Earth because they all have metallic cores, so made of metal, and rocky surfaces. Okay, so the moon, again, not the focus of this video, but it's a very interesting thing to look up. Okay, was formed, this is the best theory we have, in a collision between the early Earth and another early planet. Okay, and the debris that came off that collision formed the moon. Okay, and just a little bit of a note about the outer gas planets. Okay, there is gas giants, but they're not entirely gas all the way through. Okay, so Jupiter, Saturn, Uranus, and Neptune, okay, were formed in the colder outer system. So that makes a difference because the temperature actually causes the gases to act in a different way. Okay, so they're made of gas, but they're made of cold gas. Okay, so they have atmospheres, but they're not quite, they don't behave quite as the same way as our atmosphere does. Okay, they do have rocky cores underneath, but the outer bits of the planets that we can see, or the cloud bands, okay, is obviously gas. Okay, but cold gas. It's very interesting to look that up. Okay, let's have a look at Earth. Let's focus on Earth for this video. Okay, so when the Earth first formed, it was hot, obviously very hot, and mostly molten because it was so hot. Okay, so the early atmosphere was very different to today's. They would have been formed of hydrogen and helium. The Earth didn't hold on to these in the atmosphere because they're so light, they escape into space fairly quickly. So if you think about if you buy a helium balloon, okay, it tries to obviously escape, doesn't it? If you let go of one, okay, that it will just float away, and obviously so high you probably can't see it anymore. When the helium escapes out of that balloon, it just floats off into space. Okay, our atmosphere doesn't keep hold of hydrogen or helium very well. Okay, so the second atmosphere. Okay, so after the loss of that, we then have volcanoes. Remember, it's molten still, very volcanic. They emitted carbon dioxide, ammonia, and water vapor to form a prebiotic. That means before life atmosphere. No life still at this point. Most of the carbon dioxide from the volcanoes dissolved in the oceans. Okay, remember the water vapor was also emitted by volcanoes, which cooled down to form some of the oceans, and then the carbon dioxide dissolved in it. So we've actually got a lot less carbon dioxide today still than when the Earth was near its formation. So it's a bit like if you have a fizzy drink, the fizziness is caused by carbon dioxide that's been dissolved in it. Okay, so people would put the carbon dioxide into the drink because carbon dioxide dissolves in water. And that's why as well you can get acid rain. Okay, it's a good point to remember that carbon dioxide can dissolve in water. Okay, that's why you get sort of fizzy water as well. That's carbon dioxide in water. So comets made of ice and rock. So comets very pretty objects again, often get visited by them every so many years. Probably the most famous one was Halley's Comet. I remember a comet called Hale-Bopp in 1997. Okay, that was a very bright comet, so you might get one come back again. You often can't predict them because they've got very long orbits and they pass by the Earth. They don't really collide with Earth very often now because obviously the solar system's calmed down a bit since its formation. It's quite a bit more stable than it used to be. But in the early times of the solar system, where everything was chaotic, comets hit the Earth. The comets were really made of a lot of ice and dust. It's the ice that's important here. So the ice melted and formed some more of the ocean. So the comet hitting back then was a good thing. So this prepared the Earth for life to come about. So this is when we get life. So 2.7 billion years ago, algae evolved. So what you might find in the pond. Okay, so they're still around today and in the sea. Okay, they are photosynthetic and change much of the carbon dioxide found in the early atmosphere to oxygen. Okay, so it was carbon dioxide was around, and it was the plants. So algae are a type of very simple plant. They changed it. So let's look at the process of photosynthesis. So plants, including algae and the sunflower we see here, and trees and anything other plants. Okay, they take in carbon dioxide and water. Okay, and they give out oxygen, and they make sugars for themselves. Okay, so plants actually make the glucose, the sugars, for themselves. But this is a key point of how our atmosphere changed. You go back to this slide, we've got oxygen now in the atmosphere, O2. O3 is ozone. Okay, so that was another process. Okay, that happened. So let's look at the atmosphere today. So it's changed over time, but then now we've got these quantities. So you can see it's mostly nitrogen. Okay, 78%. Oxygen is second most abundant, so the most obviously plentiful. So a lot of people get those mixed up. It's actually nitrogen. It's the most common. Then argon. Okay, argon was just around from the Earth's formation. We haven't really mentioned it much because it doesn't really play a role in anything. You often find argon in light bulbs actually, because it's inflammable, so it won't. So if a light bulb burns, it won't burn in it. If it was just oxygen in there, it will continue to burn because argon does not allow flame to burn. And gas that you may be surprised at how low amounts are carbon dioxide. Okay, so carbon dioxide 0.037. That's humans are causing that to increase, but it's still not a major part of the atmosphere. But it's got an effect, a greenhouse effect, which are other videos on. Okay, let's look at a summary then. So what I would encourage you to do is to pause the video at this point, write the questions down or type them, and go back and answer them. Okay, this is a knowledge check to make. We've gone through a lot of things, gone through a lot of Earth's history, and so this is a question to check. I'll go through the answers in the next slide in just a moment. Okay, so go through the answers. What is a nebula? So a nebula is a large cloud of gas and dust that stars and planets form from. And it's a very beautiful thing, but all we need to know is it's a large cloud in gas and dust. So why are the rocky planets Venus, Earth, Mercury, so I must have Mercury, Venus, Earth and Mars closer to the sun than the gas giants? So the rocky planets are made from heavier elements that remained closer to the sun. Okay, so why is the inner core solid while the outer core is liquid? So the inner core is under intense pressure, causing it to become a solid. So they're made of the same thing, but the inner core is under a lot more pressure. So what two parts does the mantle split into? The asthenosphere and lithosphere. So what part of the Earth do we stand on? The crust, the top part of the lithosphere. So how do we think the moon formed? That's our best theory. Early in the formation of the Earth, a planet collided with the Earth. The debris created formed the moon. Also, there's evidence for that is that the Earth rocks and moon rocks are quite similar as well. There's some evidence for that. So what gases was Earth's first atmosphere composed of? Hydrogen and helium. What gases did volcanoes emit? Carbon dioxide, ammonia and water vapour. Where did a large amount of the original carbon dioxide go? A large amount of carbon dioxide dissolved in the oceans. What solar system object brought water to Earth with them? Comets. What process did algae do, and they still do, that put oxygen in the atmosphere? It's photosynthesis. And name the 4 major gases in the Earth's atmosphere today. So in order there, nitrogen, oxygen, argon, and carbon dioxide. Thank you for joining the video today. Hope to see you in another video. Thank you. Goodbye.